2. If you watched the previous video, we covered item 1. We proposed our guide, our solution to item 1, and gave reasons to why it is that response. We are now back with item 2, and we said for questions, I know you have the question papers right there with you. And if you don't have the item, please check the description of the video. You'll find the item. Members, these kinds of lessons are good because even when you just join late, you can forward and get us where we are. You can rewind to watch what you missed. Don't forget to share, to like the video if you really like what we do, to comment, to give supplements where we are shallow. I know we even have some teachers watching us. Item 2, for those who don't have it, goes: of late, there has been outbreak of fire in crowded places like in the market. This has prompted people to buy fire extinguishers. The fire extinguisher is a substance. The fire extinguisher is a substance Q of molecular mass 99. Molecular mass. The molecular mass of the substance Q in the fire extinguisher, they are saying, is of molecular mass 99.98. That is the molecular mass. And they are saying that contains 40% calcium. So we have calcium in it as 40%. 12 as carbon. So 12% is carbon. And they are telling us the rest is oxygen. So the rest of this is oxygen. So this is in percentages. We shall look at it. Due to demand, the government, through the Ministry of Energy, has set up a factory to produce fire extinguishers. However, the manager has failed to know which produce Q could be, which product Q could be, and has approached you for help. The task goes: Part A, help the manager to know Q and give the category of the compound to which it belongs. Part B, give the suitability of the substance in the fire extinguisher that really stops the fire. Part C, give an advice to the company on the effect of the factory's existence in the area. Hint, give the fire extinguishers the acid reacts with the Q as follows. Within the fire extinguishers, we shall look at the details. So they are telling us that they have the substance they use in a fire extinguisher. But they're telling us it is made out of this substance. And they are telling us that this substance has molecular mass in this. It is made up of 3 elements, that is carbon, calcium, and oxygen, where carbon is comprising of 40%. Calcium is 40%, carbon is 12%, and the rest being oxygen. Members, in short, they are asking us for part A to determine the molecular formula for this compound. And we cannot know the molecular formula without knowing the empirical formula of it. To determine the empirical formula, members, we very well know the format. For me, as I'm teaching my learners, I always make a table and state the elements first. So in the scenario, which elements are we given? We have 3 elements. We have calcium, we have carbon, we also have oxygen. They are the elements we have. The next step, my learners always state the mass of each of them that was given. This time the mass was represented as a percentage. So what is the percentage of calcium in the compound? They are telling us it is 40%, and carbon is 12%. The rest, they are saying the rest is oxygen. So to get oxygen, we shall get 100, which is the total percentage. We subtract that of calcium, which is a 40 plus, and that of carbon, which is a 12. What we get will be the percentage of oxygen. So it will be 100 minus 52, leaving behind a 48%. So that means oxygen alone is 48%. So the next step for calculating the empirical formula, responding to part A, we always state the relative atomic masses of each of the elements. So that of calcium is always given. They are always given in the comment, in the instruction part of the first page of the question paper, or sometimes in the brackets below the item. That of calcium is 40. The atomic mass of calcium is 40. They are standard and they are always given to you. That of carbon is 12, and that of oxygen is 16. Members, I've said no need for cramming these relative atomic masses. They are always given to you. The next step for calculating the empirical formula, we always get the number of moles for each of these elements. To get the number of moles, we get the mass that was given in the question, that is 40, for example, for calcium. We divide through by the relative atomic mass for each of the elements. Here, we divide through by 40. So we shall be getting the 1 here, as also calculated there. We shall, for this one, we shall get the mass, which is a 12, divided by 12, which is the relative atomic mass. Still, we have a 1 here. And to get the mass for the number of moles for this, we shall get the mass, which is 48. We divide it through by 16. And what we get will be the number of moles of oxygen in the compound. I know you have the calculators, but mine here, my calculator is giving me the number of moles for oxygen as a 3. Members, the next step is getting the mole ratios. What are the ratios of the moles of these elements in the compound? So we shall be getting the mole ratios. To get the mole ratios, we have to state the moles first. The moles we got up here, we state them here down. So to get the ratios of these moles of the elements in the compound, we divide it through by the smallest number of moles. So the smallest number of moles here is a 1. So we shall divide it through all the number of moles we have by 1, giving us a 1 here, a 1 here, and a 3 by 1 is always what? A 3. This means that the ratio of calcium in this compound is 1. We don't represent a 1. The ratio of carbon in this compound is also 1. We don't represent a 1. And the ratio of the oxygen in the compound is a 3. So this becomes the empirical formula of the compound. If you can rewind the video, they told us to deduce the formula of the compound and state the category of the compound it is. But we have to make use of this molecular mass. This means this is the simplest formula. Then what is the actual formula of the compound? So this formula is representing the simplest ratios of each of these elements in the compound. Now, what is the actual formula of the compound? The actual number of moles of these elements in the compound. So we shall only get them by determining the molecular formula. To get the molecular formula, we shall get the total number, the sum of all the atomic masses of the empirical formula we obtained, multiplied by any unknown, equaling them to the total mass, which is 99.98. So what we shall be getting will be the actual number. So the n is representing the actual number of moles of each of these ones in the formula. So here we shall have we know the atomic mass of calcium. The weight of one atom is 40. We shall multiply it by how many atoms of calcium do we have in this simplest formula? It is 1 times 1 plus what is the weight of one carbon atom? It is 12 times the number of atoms we have in the formula, which is 1, plus the weight of one oxygen atom, which is 16, times the number of atoms of oxygen in the formula, which is 3. All of them multiplied by the predicted number of moles, or the predicted actual ratios of each of them in the compound, which is represented by any unknown of your choice. So the n is representing the actual ratios of each of those elements in the compound. So equivalent to the total mass, which is 99.8. So we shall have a 40 here, plus a 12, plus a 48, multiplied by the actual number of moles of each of the elements, equivalent to the total mass of the compound. So for there we shall have a 48 times a 40, plus a 40, plus a 12, giving us 100, and 100 multiplied by n is 100n, giving us 99.98. So we shall divide through by 100 such that we get the actual mole ratios. So this n be, so we shall have 99.98 divided by 100, giving us 0.9998, which is approximately 1. So the actual number of moles of each of these elements in the compound is 1. So we shall bring it and put it in the formula, which was, the simplest formula was this. Since our N is 1, meaning that the actual formula of the compound is this. This is the formula the examiner wanted, or the set of the item wanted. The category of the compound so this is our substance Q. So the category of this compound, it is an inorganic compound. Remember, the compounds may be organic if they have carbon hydrogen bonds in them. They may be inorganic if they lack carbon hydrogen bonds in them. The compounds may be covalent if they are formed between a reaction between a metal or an interaction between a nanometal and a nanometal. Or it may be ionic if it is formed between an interaction between a metal and a non-metallic element, or a metal and multiple non-metallic elements. So this means you could use one of the two. This element may either be inorganic, it is an inorganic compound for the reason I've just given, since it lacks carbon hydrogen bonds, or alternatively, you may say it is ionic, since it is an ionic compound, since it is formed between a metallic element, calcium, and a non-metallic radical, a carbonate, formed by ionic bonding, formed by or joined by ionic bonds. So that is what that was what was the intention of the of the item setter for that part A. For part B, they are asking, give the suitability of the substance in the fire extinguisher that really stops the fire. Members, what are those properties of this substance in the fire extinguisher that makes it stop fire? The part of this substance, or the product of this substance that may put out fire, not this very substance, but the product of it that can put out fire, is carbon dioxide. But this item setter is stating it that we give the suitability of this substance that make it suitable, or the properties of this substance that make this substance suitable for putting out fire. So we are going to give the properties that make this substance suitable for putting out fire. Among these ones, this is part B. Carbon dioxide does not support combustion. One of the properties I'm not going to write the explanation, I'm just going to talk about it. Remember, the fact is that when we calculate for the atomic masses of each of these gases, oxygen, which is, when we calculate for the atomic mass, it will be 32. And carbon dioxide, which is written like this, when we calculate for its molecular mass or molecular mass, will be a 44. On 32 and 44, which of the two is heavier? I think 44 is heavier than 32. So this means when carbon dioxide is introduced in any space where there is fire, since it is a heavy gas, it will displace the oxygen, which supports burning, from around the area where it is introduced. So the area will be free from this oxygen. And remember, any fire without oxygen does not continue. And this space will be filled by the carbon dioxide, which is actually a non-burning gas. Another property that makes carbon dioxide a suitable gas for putting out fire, this carbon dioxide cools fire. Members, this carbon dioxide has a property of expanding quickly when exposed to heat. As it expands, it cools easily. As it cools, it also cools the areas around the fire or the burning place. And remember, for anything to burn, it must first get that temperature of fire, dries up so that it can easily burn. So when the carbon dioxide is exposed to such an area, it cools that place. As it cools, it reduces the temperature of the fire in that place where it is introduced. And as the temperature of fire reduces, it also slows down the burning rate of the fire. It slows down combustion of anything that is burning. But this is as a result of fire, of carbon dioxide being good at cooling the fire. The carbon dioxide is non-conductive. Remember, the carbon dioxide is non-conductive. Being non-conductive, it means that it can even be used to put out electrical fires. Without causing electric shocks or short circuits. Like water or from fire extinguishers. Remember, water conducts electricity, slightly conducts electricity. So when you use it, in most cases, you are likely to cause further short circuits that will cause more fires. But when you use carbon dioxide, being non-conductive, it will not cause those circuits that would promote more fire outbreaks. The carbon dioxide are talking of forms no residue. We are only talking about carbon dioxide in line with putting out fire. Because it's the intention of the item set when I look at it. He's ending with of the substance in the fire extinguisher that it really stops the fire. So it forms no residue. When you use the foam, let's talk of foam extinguishers. The foam usually dries up when used, and when it dries up, it also becomes prone to the fire. It can even also catch fire when dry. And the water, we very well know that the water itself, you cannot use water in server rooms or laboratories. You know the reasons. In most cases, when water is exposed to some of the chemicals, it catches fire. For example, when you expose it to sodium or potassium, to reactive metals, it will obviously start more fire. But the carbon dioxide forms no residues. This makes it suitable for use in some environments, such as laboratories and server rooms. So we have very many other properties that make carbon dioxide a suitable material for putting out fire. And the last task we are asking us, as you comment, you share your ideas for that part. So we welcome Nazarene Media is with us. Tony Joffle is with us. Dega Daniel. Thank you. Dega Daniel likes the spirit. Thank you. And amen. All Wisdom University Deep Planning is saying that thanks a lot, sir. We've benefited a lot from you and Mto Online at large. God bless you. Amen. Welcome other friends. Share with your friends about us. Invite more of them. If you're not part of us, please subscribe. And if you're not part of our WhatsApp groups, reach us via this number 0703 278 231. You can be part of us. Students are exploring and sharing a lot in the groups. There are lots of students there who share good ideas about academics, good work. So don't fail to be part of the group. Don't fail to get updates whenever we are making these lessons. Just tap the bell after subscribing for updates. Members, for the last part, they're asking about the effects of carbon dioxide. When you burn this substance, of course, the burning of or the combustion of this substance results into formation of carbon dioxide. We very well know carbon dioxide is a greenhouse gas. And when the greenhouse gases accumulate in the atmosphere, they destroy the ozone layer. And once the ozone layer is destroyed, we know the results, that is accumulation of heat on the Earth's surface. As the heat accumulates on the Earth's surface, we expect desertification as the impact. We can only mitigate that when we install catalytic converters in the exhaust pipes of the factories. We are Mto Online, and this is Teacher Alan. I beg to end this lesson here. Let's meet shortly in the next item.